how to find the area between curves with respect to x. So now we're going to talk about how to find the area between curves with respect to y. iPad students, were you guys able to find the notes? Okay. So now this is just an alternate way to do these problems because sometimes it's actually easier to set them up with respect to x, or sorry, with respect to y. Okay. So before you guys write anything down, I just want you guys to pay attention. This is a problem that we did yesterday. This is one of our examples. So what I want you guys to hopefully remember from yesterday is that this curve right here is y equals square root of x. And this line right here is y is equal to x minus 6. If I want to find the area between the curves with respect to x, remember it's top function minus bottom function. Can you guys pay attention? Top function minus bottom function. So this is the top function always, okay? But which function is the bottom function at the beginning? Y equals 0, okay? So this is the bottom function up until which number? 6. So do you guys remember, don't write this down, just watch. You guys set this up as the integral from 0 to 6 as the square root of x minus 0 dx plus the integral from 6 to what? To 9 of top function minus bottom function. So do you guys see how we had to split this into two integrals? Okay. Sometimes it's actually easier, instead of setting this up with respect to x and drawing two integrals, we can do this with respect to y instead. So it's just a different way to do this. Okay, so now you guys can write. So do you guys agree that if I want to find the area with respect to x, we did top function minus bottom function? So what do you guys think we're going to do if we do it with respect to y instead? Right function minus left function. Okay, so instead of doing our bounds on the x-axis from 0 to 6 and then from 6 to 9, we're going to do our bounds with respect to y. So what's our bounds with respect to y? Hey, good morning. There's donuts. 0 and 3, okay? So if you guys look with respect to y, if I'm doing right function minus left function, do you guys see how this is my right function always? And then this is my left function always for this gray area. How many integrals would I have to write then? Just one. So it actually, in this problem, is actually easier to do with respect to y. So all we're going to do is set it up, and then I'll show you guys how to do this on your calculator, okay? So with respect to y, the only issue is, do you guys see how this is written as y equals? I need this as x equals instead. So you have to solve the equation for x instead. So how do I get x by itself? What do I do to both sides to get rid of the radical? Square both sides. So this is going to be y squared. And then if I want to get x by itself here, what do I do to both sides? Add 6. So this is x is equal to y plus 6. So on my graph, this is x is equal to y plus 6. This now is x is equal to this y squared. So this is my right function. And this is my left function. Okay, is everybody cool with that? Does that make sense? Now, since we're doing it with respect to y, what are my bounds? 0 to 3, so the area is going to be equal to the integral from 0 to 3. Which function is my right function? So y plus 6 minus y squared. Good. Am I going to write dx? What's my variable? So this means with respect to y. Okay? And then you do the antiderivatives. And then what's nice is this gray area didn't change, right? Shape. It didn't get bigger or smaller. Whatever you get for this should be the same thing we got when we did this yesterday in 8.4. Where's it at on my iPad? This is embarrassing. So we set this integral up yesterday. This number, whatever this area is, should be the same thing as we're doing right now. Okay? All right. So one thing I want to point out to you guys is Whenever we do this on our calculator, what is the dummy variable when we do math 9? What is the dummy variable that we always pick? X. But what do we have on paper? It doesn't matter. So when you guys set this up on your calculator, you would still do the integral from 0 to 3 of x plus 6 minus x squared dx. Your calculator, it will still give you the same answer, and then we're good. Okay, you don't have to do it right now, but I'm just letting you know, even though we wrote y on paper, on your calculator, you'll still do x. Bless you. Okay, so we're not actually going to find this number right now. I just want to have you guys set it up. Okay, questions? Okay, set up the integral to find the area bounded by x is equal to 3 minus y squared and x is equal to y plus 1. So we're going to do this with respect to y. So I just want to show you guys, whenever I write with respect to, this is my shorthand of doing that. WRT, with respect to y. So that means my integral is going to have a dy. So what we need to figure out, guys, is what is my right function and what is my left function since I'm integrating with respect to y. So this right here is already solved for us for x. This right here is already solved for us for x. So we don't have to do any extra work here. But just by looking at these curves, let's be smart. This seems like a parabola, right? Which one looks U-shaped? This one, right? So this right here is my U-shaped graph. And then what type of function is this? It's linear, right? So this should be my linear function. So what is the right function, the green or the blue? The green, right? So this is my right function, which makes this my left function. The only other extra thing I have to do for this problem is figure out my bounds. So luckily, do you guys see how this crosses at a nice value? And this crosses at a nice value? If it didn't cross at a nice value, what I mean by a nice value is, do you guys see how this is like a nice point on the graph? This is a nice point on the graph. Remember yesterday we practiced doing the intersections on our calculator to figure it out, but since it's nice numbers, then we're good. So if we're integrating with respect to y, I need the y values. So what's the lower bound? -2. -2. And then what's my top bound? 1, good. Of right minus left, so it's going to be 3 minus y squared minus y plus 1. And then what goes at the end? dy. Okay, I haven't graded your quizzes yet. I literally just picked them up from my basket and put them safely somewhere else. I'm noticing by flipping through them, some of you guys are forgetting to put this. You can't forget to put that, guys. You have to write that when you're integrating. Okay, so please don't forget to write that when you guys are doing an integral. Okay? All right, let's actually practice doing this by hand. Okay, so let's simplify. So distribute the negative. So this is going to be the integral from -2 to 1 of... Do you guys agree that this will become -1? What's 3 minus 1? 2. So 2 minus y squared minus y dy. So nothing changes, guys. I'm just finding the antiderivative. What's the antiderivative of this? 2y minus y cubed over 3 minus y squared over 2 from -1 or -2 to 1. All right, so if I plug in 1, I'm going to get 2 minus 1/3 minus 1/2 minus, if I plug in -2, 2 times -2, it's -4, What is -2 cubed? -8, but minus -8 becomes plus, so plus 8/3. If I plug in -2 and square it, I get positive or -4? Positive 4, so minus 4 halves, which is the same thing as -2. And then we got all the fractions. What would be my common denominator? 6. So it's going to be 12/6 minus 2/6 minus 3/6 minus -24/6 plus 16/6 minus 12/6. So what is this? 10/7/6. -8 minus 12 is -26. Minus becomes a plus. So this becomes 27/6, which reduces to 9/2. We did this one yesterday, huh? These numbers look familiar. All right, this last problem sucks. And the problem that these guys chose for this one, they even said in the video that they made that this is a really hard problem, harder than ones that you guys will see on your homework. Okay, so I'm going to do my best to explain it to you guys, but just understand the ones on your homework won't be like this kind of tricky, okay? So you guys will have a problem on your homework that's like this, where you're going to be given a graph with a bounded area, and it wants you to set it up if you're going to solve it with respect to x, and then also set it up to solve it with respect to y. You're not actually solving it. You're just setting it up, okay? So let's do it with respect to x first. So with respect to x, remember this is top function minus bottom function. So if I wanted to do this with respect to x, the bounded area, where does the integral start on the x-axis? Where does the area begin on the x-axis? 0. And where does it end on the x-axis? It looks like it ends right here. Do you guys agree? Which means, what do I need to do to figure that out? I have to graph it on my calculator. Okay, I'm going to save us time because I already did it. I'm going to save us time and just give you guys the point so we don't spend 30 minutes doing this. Okay, so this point right here, let's label these. This point right here is 0, 1. This point right here is 0.5, 1.75, and this all comes from your calculator. This point right here is ugly. 1.36602, and it keeps going, but this is just for the sake of setting it up, 0.13397. Okay. So do you guys agree that I can do this because I have my iPad, but that you guys can see the colors, but it's kind of hard to do with the pencil. But do you guys agree that this is the top function at the beginning, and then this is the bottom function at the beginning, or at the beginning? Okay, but is this always the bottom function? It is. But is this always the top function? Yes or no? You guys follow me? What type of function is this right here? It's linear. What type of function is this? Quadratic. This function is also quadratic. This is the top function at the beginning. Do you guys agree that this quadratic is the bottom function? Okay, but is this function always the top function? No. Okay, so what I'm going to do is I'm going to break this up into two areas. Can you guys see the purple? So at the beginning, this graph starts at 0. So the area with respect to x would be the integral from 0 to what x value did I draw that purple line? 0.5 of the top function minus the bottom function. So this little triangular region right here, which of these is the top function? Which one of these is linear? This one, right? Because it doesn't have a squared. So it would be 3/2 x plus 1 minus, now this is something I hope you guys remember. This is the bottom function, right? Which direction does this parabola open? Up. Which one of these does the parabola open up? The first one or the second one? Second one. Good, because is the a value negative? It's positive, right? So this is your bottom function at the beginning. Now, since I'm integrating it with respect to x, what do I write here? Dx. Okay, so it's this area plus this area. So plus, now I'm going from 0.5 to here, because this is where the area ends on the x-axis. So it's going to be the integral from 0.5 to 1.36602, whatever, of what is the top function now? 2 minus x squared, because it's the parabola that's negative. So 2 minus x squared minus what's the bottom function? X minus 1 squared dx. Done. We're not actually solving that. It's just setting it up, this is honestly probably the hardest part. Same thing when we get to volumes and we're spinning around axes here in a couple weeks. Setting it up is the hard part. Once you set it up, it's just integrating it or just using our calculator. Okay? Now we're going to do it with respect to y. Okay, this part is gnarly, so I'm going to do my best. The first thing I need to do is, do I want these as y equals if I'm going to integrate it with respect to y? I need all these as what? X equals. So stay with me. Do you guys agree that this right here is this function? Okay, so if I solve this, I'm going to get y minus 2 is equal to negative x squared. And then I'm going to divide both sides by negative 1. So negative y plus 2 is equal to positive x squared. And then what do I need to do to both sides? Square root. Now this is where this problem gets hard. When you take the square root of something, what's in the front? Plus or minus. So this is plus or minus the square root of negative y plus 2 is equal to x squared. Okay, so x. So this is where this gets tricky. Our parabolas have a vertex, correct? So on one side of this is the negative square root of negative y plus 2. On the other side of this is the positive square root of negative y plus 2. What's nice about this problem is, do you guys notice our area is on the positive side of the vertex? So do I really care about the negative part? No. So I only care about the radical part. So this right here, I'm going to highlight this. This right here, this entire graph right here is going to be square root of negative y plus 2, because we need that in order to do the integral. Okay. Now for the middle part. How do I solve for x? What do I do first? Square root both sides. So I have plus or minus the square root of y is equal to x minus 1. Add 1 to both sides. So x is equal to square root of y plus 1, or x is equal to negative square root of y plus 1. So now, when we graph parabolas, we always do it with respect to x. So we have a vertex, okay? Because we have a negative and a positive root, the way that this gets broken up into two graphs is by the vertex. So do you guys see how the vertex is right here? Okay, so here I do have to include both. So the negative part is going to be the part to the left of the vertex. The positive root is going to be the part that's to the right of the vertex. So I'm going to highlight this in orange. That's what this is. And then this part I'm going to highlight in, let's do purple. So this is going to be negative root y plus 1. This is going to be positive root y plus 1. Okay. We have one more function to do, and it's nice because there's no squareds. We just have to solve for x. How would I solve for x? What? Subtract 1? Yeah. How can I get rid of the fraction? Multiply by the reciprocal. So if I multiply all of this by the reciprocal of this, I'm going to get 2/3 y minus 2/3 is equal to x. So this function, I'm going to highlight in green, is going to be all right. Now here comes the fun part. Now we get to break this up. So at the beginning, you guys are going to have to do a lot of thinking because it's a different mindset of switching between x's and y's. So do you guys agree that with respect to y, that means right minus left? Right? You guys with me? But the bounds go from what? Bottom to top? Because you're doing the y's. Okay, so where does this integral start on the y-axis? What's the lowest number on the y-axis this area touches? 0, okay? So this is going to be right small, 0, 2. Now, right now, this right here is this red graph right here. At the very beginning, this is the right function, the red graph. Oh, I'm sorry. No, it's not. My bad. It's the orange. This orange part is the right part at the beginning. What is the left function? What color? Huh? I can't hear you. What color? Purple. Good. So the beginning, yes, the beginning is orange, the right part, and the left part is the purple. So that's why I color coded it to help us out. What is the orange graph at the beginning? Square root of y plus 1 minus the left function, which is the purple, which is negative root y plus 1. What goes here? dy. Now, up until this point right here, the intersection point, what is the y boundary? Yes, 0.13397. Okay, so basically, I'm going to erase this now. This is one region. Where it intersects is another region. And then we have a third region. Does that make sense? All the intersection points is how we break this up. So how many integrals am I going to have? 3. So this is my first one, orange minus purple. What's this second one going to be? This is like red. Red minus purple. And the last one's going to be red minus green. Does everybody follow me? Okay, so we can just use the intersection points to help us figure this out. So the red graph, so the middle part, so plus the integral from right minus left. So it's going to be the square root of negative y plus 2 minus purple. So negative root y plus 1 dy. And then we're going to use the y's. So this area right here, guys, do you guys see how this is the y where it starts? So that's going to be your lower bound. So 0.13397, is that right? Yeah. 2, what's the upper bound? 1. Okay, and we have one more. Plus the integral from, what's my lower bound? 1, what's my upper bound? 1.75 of, what's my right function? What color? Red. See you later. Red, so the red function was square root of negative y plus 2 minus, what color is the left function? Green. So it's going to be the 2/3 y minus 2/3 dy. Ugh. You guys won't have anything like that in your homework that's hard like that, but hopefully that makes sense. Where the functions cross are going to help you figure out what your boundaries are. So like when we did it with respect to x, did you guys see how we did it from 0 to 0.5? Because on the x-axis, this is where the functions crossed. And then we did it from 0.5 to here, okay? So if you guys had a choice, which one was easier, x or y in this problem? X. So you'll only pretty much do this if they force you to do it. But just understand, should the answer change? No, shouldn't this area, if it's like 1.3, shouldn't it still be 1.3 regardless? Okay, it's just a different way to solve it, okay? All right.